Okay. Good morning, students. So today we have last lecture on waves, and we have solved some numericals in the previous class. So today also we will solve some more numericals, some more different numericals on the chapter called waves. So numericals on waves. Already we have solved some numericals in the previous class. Some more and we will finish it. Okay. Read the question. Number you only know. Number whatever it may be. So estimate the speed of sound. Estimate the speed of sound. Take pen and paper. Pause the video. Take pen and paper if you are not taken. Understood? And then write. Write the question. Estimate the speed of sound in air at STP by using a Newton's formula and a Laplace formula. Estimate the speed of sound in air at STP. Estimate the speed of sound in air at STP by using number one Newton's formula and number 2 Laplace formula. Number 1 Newton's formula and number 2 Laplace formula. Give list of. Estimate the speed of sound in air at STP by using a Newton's formula. Number 1 Newton's formula and number 2 Laplace formula. Give list of. The mass of 1 mole of air is equal to, given in the question only. It is in the question only. The mass of 1 mole of air. The mass of 1 mole of air. The mass of 1 mole of air is equal to, they are given in the question only, it is in the question, 29.0 into 10 to the power minus 3 kg. 29.0 10 to the power minus 3 kg. For air, ratio of specific heats. Ratio of specific heats is, it is gamma is equal to 1.4. They have given in the question only. So this is question. Question is completed. Now solution. In the question they are asking to find the velocity of sound in air by using a Laplace formula. Velocity of sound in air by using Laplace formula, and velocity of sound in air by using Newton's formula. First they are asking by using Newton's formula. After that they are asking velocity of sound by using a Laplace formula. Okay, so now, and we know that already we have studied in the theory classes, the velocity of sound in air according to Newton is given by V is equal to under root P divided by rho. P is called pressure. At STP pressure we know, so density we don't know, so density we have to calculate. So the given is that the mass of 1 mole of air they have given, but they did not given the density, so you can calculate the density. So density of air is equal to, so it is rho, that is mass of 1 mole of air. Mass of 1 mole of air divided by volume of 1 mole of air. Volume of 1 mole of air. And volume of 1 mole of air is not given. And then how we will do? So density of air, rho is equal to mass of 1 mole of air they are given. It is 29.0 into 10 to the power minus 3 kg. And now the volume of 1 mole of air is not given. Then how we will do? So volume of 1 mole of air, that is standard value we have to remember. At STP, the volume of 1 mole of any gas is 22.4 liter. At STP, the volume of 1 mole of any gas will be 22.4 liter. That is we have studied in the theory classes only. So this is in liter, converted into meter cube. It is 29.0 into 10 to the power minus 3 kg as it is. And this is in liter. So 1 liter is equal to 10 to the power minus 3 meter cube. So we'll get 22.4 into 10 to the power minus 3 meter cube. So now kg per meter cube, we'll get density. So on calculation you will get it as 1.29 kg per meter cube. This is the density of the air. We have calculated. So now first one. So according to Newton, velocity of sound in air is V is equal to under root P divided by rho. P is pressure, and pressure at STP, here I will write. Actually here only we have to write. So pressure at STP, that is standard pressure, that is 1 atmospheric pressure, 180 m or 76 centimeter of Hg in the. Okay, so you can write pressure at STP as 1.013 into 10 to the power 5 Pascal. We know this already. 1.013 into 10 to the power 5 Pascal. So therefore V is equal to, substituting the value, so V is equal to under root 1.013 into 10 to the power 5 and divided by, this is much density, it is 1.29 kg per meter cube. This is kg per meter cube, and this is Newton Pascal, that is Newton per meter square. So after calculating you will get, so do the calculation. Calculation is left to you people only. You just make it as even number, 10 to the power, make 10 to the power as even number and do the calculation. Then after calculation you will get the answer as 280 meter per second. The velocity of sound in air as per Newton is 280 meter per second. So 280 meter per second, correct, 280 meter per second. This is the velocity of sound in air according to Newton. So now according to Laplace. Now number 2, according to Laplace, velocity of sound in air at STP is given by formula V is equal to under root gamma P divided by rho. This is Laplace formula. V is equal to under root gamma P divided by rho, and V is equal to under root gamma. Gamma is ratio of specific heats, and ratio of specific heats for air is 1.4 and pressure is 1.013 into 10 to the power 5 and density is 1.29. So on calculation you will get the answer. Do the calculation on your own. Use the small calculator, you can do it. Convert this 10 to the power 5 as an even number. Then the calculation becomes simple. Either you make it as 10 to the power 4 or you make it as 10 to the power 6. Then do the calculation, then take the 10 to the power out of the root. It will be easy. Okay, so the answer will come so to be 331.5 meter per second. 331.5 meter per second. This is the velocity of sound according to Laplace. So this is the value of velocity of sound according to Laplace, and this is the velocity of sound according to Newton. Then who is correct? You have already studied in the theory class. Okay. This is actually you might have did in the theory class, but it is there just we are did. Okay. So next question. Write down the next question. Next question. At what temperature will the speed of sound? At what temperature will the speed of sound be double? At what temperature will the speed of sound be double? Its value at 273 Kelvin. Question mark. At what temperature will the speed of sound be double? Its value at 273 Kelvin. Only one sentence and 273 Kelvin. Question mark. Read the sentence properly and try to understand the question properly. Then you try to solve the question. So understanding the question is important. Or the same question can be also written like this. The same question can also be given like this. R anta barkodbekadre. If you want, you write it as R. Calculate the temperature at which the speed of sound will be 2 times its value. calculate the temperature at which the speed of sound will be 2 times its value at 0 degrees Celsius. Calculate the temperature at which the speed of sound will be 2 times its value at 0 degrees Celsius. So, we have to calculate the temperature. Directly I will write given. So, we have to calculate the temperature at which the speed of sound will be 2 times that is let us say this temperature as T2, then that velocity of sound at that temperature will be 2 times the velocity of sound at some other temperature. Let us say that as V1 and that as T1, that corresponding temperature as T1. So, V1 is the velocity of sound when the temperature is T1, and V2 is the velocity of sound when the temperature is T2. That is understood. We have studied already in the theory class. And temperature T1 they have given as 0 degrees Celsius, and that 0 degrees Celsius is same as 273 Kelvin. Okay. And now we know that how velocity of sound is related to temperature. That is, we have studied in the classes. The factors affecting the velocity of sound. It is velocity of sound is directly proportional to the square root of temperature. So, velocity of sound is directly proportional to square root of absolute temperature, that is V proportional to square root of temperature, that is temperature in Kelvin scale. So, it is we can write this formula as V1 proportional to root of T1 and V2 proportional to root of T2, correct. So, therefore, we can write V2 divided by V1 is equal to under root T2 divided by T1, simple. Proportionality sign is there. So, when you remove the proportionality sign, there will be a constant, and constant. When you divide these two, that constant will cancel. So, you can write V2 by V1 is equal to under root T2 by T1. So, therefore, and they are given V2 is equal to 2V1. So, 2V1 divided by V1 is equal to under root T2 divided by T1. T1 is known, it is 273. So, therefore, V1 cancel. So, 2 is equal to, so 2 square is equal to T2 divided by 273, correct, squaring on both sides. So, square root is there, so square on both sides. So, 2 square is 4, so T2 is equal to 4 into 273. So, T2 is equal to, the answer will come so to be 1092 Kelvin. At a temperature of 1092 Kelvin, the velocity of sound will be twice the velocity of sound at 0 degrees Celsius, that is at 273 Kelvin. At 273 Kelvin, what is the velocity of the sound? So, double of that value will be there at a temperature of 1092 Kelvin. Understood? Okay, hope you understood this one. Next question. Solve the next question. Write the next question. Speed of sound in air is 332 meter per second at STP. Next question. Speed of sound in air is 332 meter per second at STP. Speed of sound in air is 332 meter per second at STP. What will be its value in hydrogen at STP? What will be its value in hydrogen at STP? Speed of sound in air is 332 meter per second at STP. What will be its value in hydrogen at STP? If density of hydrogen at STP is, if density of hydrogen at STP is 1/16th, 1/16th that of 1/16th, like this, you write it like this, 1/16th that of air, 1/16th that of air, question mark. if density of hydrogen at STP is 1/16th that of air, question mark. Okay. So read the question properly and try to understand the question properly, then you try to solve, you will get the answer. Okay. See, read the question. So what they have given first, the speed of sound in air. So they are given the speed of sound in air is 332 meter per second. They are given the speed of sound in air at STP. At STP is 332 meter per second. Okay. What will be its value in hydrogen at STP? That is speed of sound in hydrogen. So that is in air. I'll write A. I'll write this as H. No problem. Okay. Or you write this as V1 and this as V2. V2 is velocity of sound in hydrogen and V1 is velocity of sound in air. Okay. And they are given, and V2 is equal to question mark at STP only. At STP. What will be its value in hydrogen at STP? If density of hydrogen at STP is 1/16th that of air, that is density of hydrogen at STP is 1/16th that of air. They have given it is rho H. Rho H is density of hydrogen is equal to 1/16th the density of air. Okay. So now we know that the speed of sound in air is given by the speed of sound is given by V is equal to under root gamma P divided by rho. This is the formula. Gamma is called ratio of specific heats and P is called pressure and rho is called density of the medium. So for air and hydrogen, so that is the ratio of specific heat, gamma is same and P is also same. The value of gamma and P is same because this is STP only. The gamma value is same and P is same. P is same because both are asking at in air medium also at STP, in hydrogen medium also at STP only. So P is same. The value of gamma and P is same for both air and hydrogen gas. Okay. So therefore in air the formula will be velocity of sound in air VA is equal to gamma P divided by rho A. So in hydrogen gas velocity of sound, that is VH, is equal to under root gamma P divided by rho H. So now divide these two equations. It is VH divided by VA. VH divided by VA. We want VH, that's why I have written it is in the numerator. Okay. VH divided by VA. So VH is that one, that is gamma P divided by rho H, and VA is gamma P divided by rho A. So gamma P will cancel because gamma and P both are same. So therefore VH divided by VA is equal to under root of, so that is rho A divided by rho H, and under root of rho A divided by rho H, that is density of hydrogen. They are given 1/16th the density of air. So no density of air cancel. So you will get VH divided by VA is equal to under root of 16, and under root of 16 is 4. So VH is equal to 4 times the velocity of in air. Simple. And the VA is given already. So therefore right here. So VH is equal to velocity of sound in hydrogen is equal to 4 times the velocity of sound in air. Velocity of sound in air was how much? So that is how much it was? What's the value? Just now I remember 332 maybe. Okay. 332. So 332, and on calculation you will get this value as 1328. 28 meter per second. So velocity of sound in a hydrogen is 1328 meter per second. Okay. So this is the numerical. Understood? Okay. Write down the next numerical. Write down the next numerical. The ratio of densities of oxygen. The ratio of densities of oxygen and nitrogen. The ratio of densities of oxygen and nitrogen is. The ratio of densities of oxygen and nitrogen is. The ratio of densities of oxygen and nitrogen is 16:14. The ratio of densities of oxygen and nitrogen, it is ratio of oxygen divided by nitrogen is 16:14. You please stop. At what temperature the speed of sound in oxygen will be equal to its speed in nitrogen? At what temperature the speed of sound in oxygen, the speed of sound in oxygen will be equal to its speed in nitrogen. Its speed in nitrogen at 14 degrees Celsius. The temperature of nitrogen they are given. Temperature of nitrogen, that is T is equal to 14 degrees Celsius in degrees Celsius. Here question. At what temperature the speed of sound in oxygen will be equal to its speed in nitrogen at 40 degrees Celsius. Whatever the velocity of sound in the nitrogen at 14 degrees Celsius, same velocity of sound must be there in the air medium, in the oxygen medium, and that is possible at which temperature? That is temperature of oxygen we have to calculate. Temperature of oxygen we have to calculate. Understood? So let us say T dash is equal to question mark, or this is temperature of nitrogen and this is temperature of oxygen, T naught is equal to question mark. Okay. So now how to solve this problem? See here, I will tell the solution. So we know that the velocity of sound in a gaseous medium or in a medium is given by V is equal to under root gamma P divided by rho. The velocity of sound in a gaseous medium or in air medium is given by V is equal to under root gamma P divided by rho. And now we know that, so PV is equal to RT. We can apply that formula by considering the gases as ideal. PV is equal to RT. So volume can be done as mass divided by density is equal to RT. So therefore P by rho is equal to RT divided by M. We can write like this. This P by rho can be done as RT divided by M. So therefore the velocity of sound V is equal to gamma into P by rho can be done as RT divided by M. Understood this formula? So V, velocity of sound in a gaseous medium, is equal to under root gamma RT divided by M. Gamma is called ratio of specific heat, R is called universal gas constant, temperature, T is temperature, M is mass of that gas, molar mass of that gas. Okay. So now this formula for oxygen. So for oxygen, we will write this formula for oxygen. It is V naught is equal to under root gamma R T naught divided by M naught. That is temperature of oxygen, or the temperature you can write in degrees Celsius. That is, if you write in degrees Celsius, we will get that as T naught plus 273. T naught plus 273. That is, in a degree Celsius I will write small t, and in Kelvin I will write capital T. Capital T means temperature in Kelvin and small t means temperature in degree Celsius, or this formula only you can write gamma RT plus 273 divided by M. And now for oxygen, T naught plus 273 divided by M naught. Okay. So now for nitrogen the formula will be, it is Vn is equal to under root gamma R into Tn, temperature of nitrogen, plus 273 divided by Mn. Okay. Now divide these two equation and not divide. No, they have given that equal. That is, they have given that velocity of sound in oxygen is equal to velocity of sound in nitrogen. At which temperature they are asking. So therefore, equating both the formula, it is gamma R into T naught plus 273 divided by M naught. Okay. Under root gamma R into Tn plus 273 divided by Mn. And gamma, the ratio of specificity is same for both, that is nitrogen and oxygen, and R is also same. So gamma and R both will cancel, and you can write, so it is T naught plus 273 divided by Tn plus 273 is equal to M naught divided by Mn. Can you write like this? And they are given density. They are given density, the ratio of density. The ratio of density they are given means ratio of mass they are given. Ratio of densities of oxygen and nitrogen. Ratio of densities of oxygen and nitrogen, no problem. So density they have given means, so the ratio of density will be same as ratio of mass. So therefore, M naught divided by Mn will be equal to 16 divided by 14. So therefore, you can write that formula. It is by using this value, you can write it is T, and also Tn, temperature of nitrogen is given, that is 14 degrees Celsius. So therefore, T naught plus 273 divided by 14 plus 273 is equal to 16 divided by 14. So then on simplification, so you simplify this one and get the answer. On simplification, you will get the answer as T naught is equal to 55 degrees Celsius. So this is the answer. Simplify, you only simplify and get the answer. Just do the calculation. Okay, we'll get temperature of oxygen will be 55 degrees Celsius. So at 55 degrees Celsius of temperature of oxygen, whatever the velocity of sound will be there, that will be the velocity of sound, and velocity of sound in air and velocity of sound in nitrogen will be same. And in the nitrogen, the temperature will be 14 degrees Celsius. Understood? At 14 degrees Celsius of temperature of nitrogen, whatever the velocity of sound is there, the same velocity of sound will be there in the air medium at a temperature of 55 degrees Celsius. Understood the question? Okay. So write the next question. Next two more questions you solve is enough. There are large number of questions are there. We are keep on solving. There is no end, and I will solve only two more type, and remaining try on your own. Okay. This is not only the end of the numericals. See here, how much numericals we will solve in the classroom. It is only meant that this is how the numericals you will get in the exams, or this is how the numericals will be there in the final exam. Like that, some examples, different type of numericals will do, and some more numericals you have to solve on your own. Okay. Next question. Write on the next question. A wave traveling along a string is described by. A wave traveling along a string is described by. A wave traveling along a string is described by. A wave traveling along a string is described by. Write this equation. Y of xt is equal to 0.005 sine 80.0x minus 3.0t. They are given in the question. This equation they are given in the question only. A wave traveling along a string is described by y of xt is equal to 0.005 sine 80.0x minus 3.0t, comma, in which the numerical constants are in SI units, in which the numerical constants are in SI units, in which the numerical constants are in SI units, in which the numerical constants are in SI unit. Bracket number 0.005 meter, comma 80.0 radian per meter, and 3.0 radian per second. This is in bracket they are given. It is 0.005 is in meter, 80.0 is in radian per meter, and 3.0 is in radian per second. That is how they are told. Give a list of calculate number 1 amplitude, the amplitude. Number 2 the wavelength, and number 3 the period, and frequency of the wave. Amplitude, wavelength, period, and frequency of the wave. Amplitude, wavelength, time period, and frequency of the wave. So they are asking. So how to solve this question? Simple question. So that is, so this is the equation of a progressive wave, equation of a traveling wave antandana. That is a wave on a string. A wave on a string is nothing but a wave traveling along a string is nothing but a progressive wave or traveling wave. So comparing this equation, it is comparing. Directly I will solve the question. Okay. Such kind of numericals we have already solved in the oscillation chapter. In the oscillation chapter, such kind of numericals we have already solved. So this will not be a big task for you people. Comparing the given equation of wave with standard equation of wave, standard equation of progressive wave. It is y of xt is equal to a sin omega t minus kx, omega t minus kx, or kx minus omega t. Okay, no problem. Whatever you want you can write. Sin kx minus omega t. So here you can write this formula. Y of xt is equal to a sin kx minus omega t, or you can write omega t minus kx, no problem. And the derivation, some of the books they will write like this, some of the books both. So whatever the given formula, if instead of x, if it is a t, then you write omega t minus kx, it will be x. Understood? So whatever the given equation, like that you write the standard equation. So that is, so now comparing these two equations, so you will get directly, that is A is nothing but amplitude, and at the place of amplitude it is 0.0. So comparing, so amplitude A is equal to 0.005 meter, simple. And second one B, what is there asking? Wavelength, and wavelength you will get by using the formula K, that is wave number, angular wave number. It is angular wave number K, that is we know the formula 2 pi by lambda, and that is equal to 2 pi by lambda is equal to, it is 80.0 they have given. So therefore lambda is equal to 80.0. So they have given the value like that only. So therefore you can solve this value and get the value of lambda. So lambda is equal to, so 2 pi divided by 80.0. So therefore on simplification you will get the answer. So here only I will write. So thus lambda is equal to, so what are the answer you will get? So lambda is equal to, you will get it as 7.85 centimeters. Check the answer whether it is correct or not. 7.85 into 10 to the power minus 2 meter. 7.85 into 10 to the power minus 2 meters, that is 7.85 centimeter. 7.85 into 10 to the power minus 2 meter. Okay. And next this wavelength is completed. So time period. So for that we have to take the value of omega. It is angular frequency. angular frequency omega is given by 2 pi by t, and at that place, so what is the value? 3.0. It is equal to 3.0. So therefore t is equal to, so t is equal to 2 pi divided by 3.0. So t is equal to, you will get the answer. So capital T is equal to 2.09 second. 2.09 second. So capital T is equal to, and lastly what they are asking, frequency. So and frequency will be equal to 1 by t. So f is equal to 1 divided by 2.09. 1 by 2 is 0.5. So 0.5 hertz. So f is equal to 0.5 hertz. Understood? Something 0.4849, maybe 4849, 0.48. It is 0.48 hertz. Okay. So this is how you can solve the numericals. Okay. So this much numericals is enough. Still there are a large number of numericals which you can solve, and you work it out at the home on your own. Okay.